Dietrich. And it's lovely to have also Mira, who's a fellow colleague and art therapist in Lebanon. So coming here to the U.S. to join us is a lovely honor. So thank you. We also wanted to welcome AUB alumni. We have some people here we don't recognize, so we're assuming you're AUB. This is actually close to my heart. I was born and grew up in Beirut, Lebanon, so it's an honor to have all of you here as well. And then, of course, our students here. It's lovely to have you. And then downtown GW people. So we have quite a gathering here. We hope that you'll join us for a reception afterwards where we can chat for a little bit and you can meet everyone. But welcome to GW. And I will hand it over to Juliet King, one of our faculty, who will be introducing.
Yes. Hi. Thank you so much for being here. We're so excited to host Dr. Arne Dietrich, who in our Alexandria campus, Arne is a cognitive neuroscientist who works in the psychology department at American University in Beirut, Lebanon. And his research and his work focuses on brain mechanisms involved with creativity and flow and altered states of consciousness. He has authored 2 books, Introduction to Consciousness and How Creativity Works in the Brain, both very well acclaimed, I might add, and quite popular. He has authored over 60 papers and has been invited to talk at over 100 presentations and keynote addresses across the entire world. Arne also is very prominent in the international press and has been involved in publications and press with BBC, CNN, Guardian, the New York Times, Scientific American, Time Magazine, The Atlantic, National Geographic, and has a TED Talk. I know, it's such a good talk. So I had the distinct pleasure of meeting Dr. Dietrich on the beaches of Cancun 3 years ago at the International Brain on Art Conference, which is a conference on neuroscience, innovation, and creativity. And from there, I invited him to be a keynote speaker at a symposium I organized in Indiana University, and that was 2 years ago. And also, Mira was a speaker as well. That was a symposium called 21st Century Great Conversations in Neuroscience, Art, and Related Therapeutics. And Arne also gave an additional talk for the faculty and students in the art school on creativity and flow. And so without further delay, we all welcome Dr. Arne Dietrich to give a very relevant talk on a really important topic that I assure you will be nothing less than brilliant.
Thank you. Hi everyone, it's nice to be here, and as you can see, I think this is the only slide, but there might be more. The PowerPoint is screwed up a bit, at least in this case my name. But there might be more things that are formatting changes as we go along. The first thing I wanted to see is to get a grasp of who's in the audience in terms of AUBite. So who's an AUBite and an alumnus from AUB that has come? So not that many haven't come. So most of you are from the art therapy program. Your program, right? From here?
Hands. Yay!
Hands. Okay. That is already quite informative because that means, as I often quip when I talk to people that I call brain illiterate, that are not neuroscientists, these are my fellow colleagues, that I pitch this talk slightly differently. So what I have thought I'll do is give you an overview of what has been happening in the field of neuroscience and creativity. That means the brain mechanism of creative thinking in general, and then also put into this bit of my work of where we're going. I try to do this in a sort of common sense sort of view so that you don't have any prior knowledge on cognitive psychology, computational mechanisms, neuroscience mechanisms. This sort of talk would look very different if I give it to my colleagues. But I've gotten now very used to talking to more artistic-minded people, so hopefully if I lose you, which I tend to do all the time, by putting in a lot of terminology and technical terms, please stop me, I'll explain things as I go. As neuroscientists, generally speaking, we are interested mostly into mechanisms. It is a very reductionistic field. One of the challenging things, not only for this field, but also bringing it across to people from other disciplines who are interested in this, is also to debunk a bit their overly romantic and fluffy view of creativity. Because ultimately, this has to be implemented by normal processes in the brain that are nothing miraculous or weird or strange. And once you are so uncompromisingly mechanistic, a lot of people don't like this. So you'll see a view on creativity that takes out most of these overtones of the special creative genius and so on, and these sort of things. And that is a typical thing of demystifying not only creativity, but also other higher cognitive functions. Okay? What I also do very often when I give talks around the world is to show past AUB. Now, we don't have that many AUbites in here, but that's just as fine, because for mostly people think of Lebanon and Beirut in terms of blood and guts, in terms of civil war, and AUB is a beautiful campus, one of the most beautiful campuses in the world, recognized as such. And I showed you a few pictures as well of the beautiful campus right on the Mediterranean. Okay? So the talk was on brain mechanisms of creativity, and it has a couple of components, two more main components. So the road ahead, or a sneak preview of the things to come, is that the most interesting thing to me is that I point you into the right direction in terms of the kinds of neuroscience research that's going on right now, that we need to tie to our creative ability, our ability to be in flow, to produce creative products. And I call this real mechanisms because these mechanisms are still, some of them that we haven't yet fully understood, and how they relate to creativity. Here they are. I get through them one by one. The vaudeville conception of creativity, and the fact that we need to break the beast of creativity into types. Otherwise, we have no chance of getting, because when you hunt mechanisms, you always go smaller and smaller. You're reductionistic. If we don't break this big beast into smaller chunks that we can bite off, we cannot hunt for mechanisms. I talked to you a little bit about evolutionary algorithms. Again, sort of very common sense sort of point of view. Two things, the prediction framework and the explicit extinction, that is also part of understanding how creativity works in the brain. One of the things already, as you can see these things that you've probably never seen or heard of on the screen right now, is that one of the things that I want you to be aware of is that the explanations that we are going to come up with are very, very unlikely in the future to mesh with your intuitive sense of what it is like to be creative. Mm-hmm. Your intuition of what you think is going on, what facilitates creativity, what fosters it, what makes you facilitate your own creative or creative flow, is probably not anything that you will hear in neuroscience talk. There's a disconnect there. It's a bit your experience of physics, of how the physical world works, and how it is disconnected from how it really works, quantum physics. Because quantum physics is not at all intuitive. The mechanisms that we're going to discover will also not be intuitive. You will not connect to them sort of in your own sort of intuitive ways. It's much more complicated than that. If you want to understand it, you have to get used to a few terms and points of view that are unfamiliar if you're not a neuroscientist. Unfortunately, I have to start, before you are open to these possibilities, these proposals, what I usually do is what I call my little demolition project. I have gotten quite famous for this. Last about 10, 15 years ago when I started doing this, looking at how we conceptualize creativity, also the neuroscience of creativity, and I saw a lot of misconceptions. So I've spent quite a bit of time, the first 5 years I was in the field, to demolish them, to sort of sanitize our really bad habits of thinking about creativity. And that includes this sort of overly romantic view that we all have of the creative genius, that we're going to have to dismantle in order to get anywhere with real mechanisms. Unfortunately, my colleagues, some of my neuroscience colleagues, have contributed to this, and that has also become part of the demolition project. So before I can go to the real mechanisms, I'm going to spend some time putting some common conceptions that you probably all have or at least heard of, and give their proper neuroscientific funeral. That is provided, otherwise we can't get forward. As long as you cling on to them, yeah, then you will not be open to another avenue of looking at what might be going on in the brain. I've listed down there a few publications if you're interested, and the one probably is the most recent one, the one in the bottom, that is also a fairly short one, about different types of creativity, the proposals I've made that we should, and what kind of types we're talking about. Yeah. There are also a couple of books that Juliet already alluded to, and the one probably most interesting to anyone who wants to read more about it is How Creativity Happens in the Brain, and that is on the left side. So jumping right into my demolition project. Let's start with the first one. A dud that you have all heard. It has infested the world over. The idea that creativity is in the right brain. I'm sure you heard this. So I call this the brief and frightening reign of the right hemisphere. Let me tell you a little story on how this all developed, because we're still not quite clear, one, how it developed fully, we're clear on, and how it metastasized as a vicious mutation of a virus into everybody's brains. I heard that theory in all 5 or 6 continents on this planet, depending on how you count the continent. And everybody strongly believes that's the case. It's not. The right brain theory is an example of a common thinking mistake when thinking about explanations of cognitive functions or emotional functions in the brain. I think the right brain theory ought to be treated like nuclear waste and buried for 1 million years. So to do this little thing here for you, okay? It started in the 1970s with split brain surgery. These are people who had epilepsy, and if they didn't have that operation, that epilepsy would have been fatal. It's very bad. What they do is cut the corpus callosum, which is a bunch of fibers connecting the left cortex to the right cortex. Not the left brain to the right brain, just the cortex. Yeah? These are cortical fibers, mostly. Yeah? When you cut them, you will help these epileptic patients, because when they have an epileptic focus on one side of the brain, usually it crosses the corpus callosum and infects the other side of the brain. By cutting these fibers, you prevent these seizures to spreading across the corpus callosum to the other hemisphere. Yeah? But you also prevent anything else going over from the left to the right. Things like information also doesn't go over. What is in the left will stay there and will not go over onto the right. A flurry of research in the 70s and 80s led to us understanding that these hemispheres are slightly specialized. The left has a tendency to be better at tasks that are analytical, sort of the antithesis of creativity. The right is a bit better at tasks that are synthetic. That's, for instance, why the left does language, because it's a sequential, logical task that requires analysis. One word comes after another word, and you form a sentence as you go along, as you speak. Yeah? The right is more of a holistic putting pictures or elements together to the larger picture. And it's true that some functions are lateralized. Creativity just isn't one of it. And this generalization led to, with our sort of overly romantic view of creativity, to think that the right hemisphere is the analytical one. And of course, we think of creativity as the opposite of analysis. So the right is the creative one, the left is the analytical one. Of course, you can also be creative being analytical. But that sort of morphed with the popular press into this phrenological pseudoscience that we all agree is wrong. And I wouldn't even mention this, I wouldn't certainly mention this to an audience who are neuroscientists. I mention it to you because of two things. One, the ghastly side effect this had in the general population. You can still walk into Barnes and Nobles in any bookstore really and find a book on a business seminar on how to think with both sides of your brain, or the 7 easy steps on how to tap into your right hemisphere creative potential. You can just as well ask somebody to make better use of the hippocampus. It is pseudoscience, and we know so. But once something like this, especially the way we think about explanations in the brain, goes into the general public, it becomes a life of its own, and it mutates from there. And so everybody believes it. We all know in neuroscience this is not the case. And even if it is the case, it still wouldn't be an explanation, because I would, of course, want to know how the right hemisphere does creativity. What you're having is a location, and you should not confuse a location with an explanation. An explanation is always a mechanism, yeah, that explains to you how something works, not where it is at. So when I tell you, for instance, that memory is in the hippocampus, it's the same mistake. Yeah? It's the mistake of confusing a location with an explanation. And that's the other thing. That's actually the second thing, the basic underlying error in thinking about what neuroscience can and cannot do. Providing a location does not do much or anything at all for us. We need mechanisms, and these are not mechanisms. Okay? The best manifestation of this error in thinking is actually the primary paradigm that has been used in the field for 50 plus years. It comes from a guy called J.P. Guilford, who was head of the APA in the 1950s, and he proposed a concept of how to study creativity in the brain called divergent thinking. Maybe you've heard of it. Divergent thinking. And I call this segment The Rise of Divergent Thinking and the Fall of Everything Else, because no one had ever had a good idea ever since then. And it has started to dominate the whole experimental field of creativity. The concept is that you come up with many different ideas possible, sort of as an open-ended thing, rather than, again, an analytical task where you have one right answer. Okay? The divergent thought leads to creativity. Of course it doesn't. But we'll get to that in a second. Guilford's idea morphed into a theory of everything, where a divergent thinking task became a proxy for creativity, although it isn't. Yeah. And then any research was sold as studies of creativity, when in fact there were only studies on on divergent thinking. Whatever that is, we'll see that divergent thinking is an amorphous monster that leads to phrenology. We have no idea what it is. Yeah? So I call this part, this is how the thing is set up. I call it the Rocky Horror Pixel Show. Because once you use these tests with a functional MRI, of course in the functional MRI you have voxels, not pixels, but it doesn't rhyme. You have to have a pixel show rather than a voxel show. This is the most common test. It's the alternative uses test, or the AUT, the infamous test, combined with functional neuroimaging. There are about 50 papers, maybe 40 papers or so, of that type in the last 10, 15 years that have been produced. And this has truly confused just about everybody, because the outcome, of course, if you give somebody the functional MRI test, some brain area is going to light up. I mean, they do a cognitive test, yeah? And then you claim, that does creativity. You have a couple of mistakes in this way of thinking, but these are the papers that have been produced. The alternative uses test is the following. You take a common object, a brick, an auto-cleaning tire, a safety pin, and you have 1 minute to come up with many different uses of that item. Yeah? That red brick, I can throw it at you. Yeah? I can use I can use it as a door stopper. I can use it to scratch my back. Yeah? I mean, whatever you come up with. Yeah? And there's a particular way of scoring it. Yeah? I've given the AUT once to a bunch of artists in London many, many years ago, and you could literally see them. Actually, we went through the whole exercise, and you could see them growing incandescent with anger that their most prized possession by neuroscientists is reduced to this. Yeah? Because the test then actually tells you whether you're creative or not. Of course it doesn't, but that's how neuroscientists a lot of them have been using it. And this is nothing short of pseudoscience. So first is the problem of the validity of the test. Now imagine the following thing. You come to an experiment on creativity and the brain. You're being led into the lab, and you're being put into a functional MRI scan. Have you ever been in one? It's a fairly noisy hum. You are in a laying position. Yeah. If you're claustrophobic, that's not for you anyway. And then the researcher says, now, please be creative. Starting now. You have 1 minute. I'm not joking. The things that you've been reading, yeah, about the neuroscience of creativity come from this paradigm. You can already see that this doesn't work. Yeah? Creativity has the dubious distinction of being very, very, very difficult to induce reliably in the lab. I can do that with attention, I can do that with memory, I can do that with perceptual processes, but creativity is very, very tough. Yeah? But that's the only hope they thought they had, and they went along with this kind of research. The main problem is also that the AUT is conceptually incoherent. It produces what I call a false category formation. Here's what that is. The idea is that creativity is associated with divergent thinking. But a moment's reflection will tell you, just a bit of thinking, yeah, that you can also be creative with a convergent thinking process. Yeah? What would he otherwise make out of Edison's inventions? A process of convergent thinking. The way Johann Sebastian Bach wrote his cantatas. Convergent way of honing into one particular type. The way you solve problems, the way engineers solve very creative problems. Yeah? So, let me do this here with you. If you can be creative using convergent thinking, and you can be creative using divergent thinking, then the obvious question arises, what is creative about divergent thinking? And no one of my colleagues is willing or able to answer that question for me. In science, we produce a control condition and an experimental condition. And the beast we are hunting is in the experimental condition. It cannot be in the control condition. We contrast these two. We hold everything as constants, and we can make cause-effect relationships along with it. If you have the beast both in the experimental condition and in a control condition, you have a confounded experiment. This is a false category formation. Almost all of what you've heard about creativity is a false category formation. The last thing, actually the last two things, the compound construct and the monolithic entity fallacy, has to do with the fact that we have no idea what divergent thinking is. We don't know how much attention processes go into it, how much memory, working memory, reference memory, perceptual processes, categorization processes, things like theory of mind, cognitive control. This is how we understand the brain. No one knows how much is in divergent thinking and convergent thinking because the rest of neuroscience doesn't use these concepts. We have a test that's not valid and conceptually and theoretically incoherent. We don't have a paradigm. That doesn't keep some of my colleagues from publishing anyway because they need tenure, but it don't work anymore. There have been a whole host of these wild goose chases of tying creativity to a whole bunch of things. None of them, they're all false category formations. Supposedly, you can read this in the literature, and in good journals too, that creativity is associated with low arousal, or defocused attention, or lateral thinking. You know what lateral thinking is? It's this concept from this guy called Edward de Bono, yeah? Who mostly writes for a business audience on fostering creativity in the workplace. He has written a few books that they have sold so much. This guy owns an island off of the coast of California. Let me repeat this in case you didn't hear what I just said. From this concept, yeah, lateral thinking, writing a few books, he has sold so many of them, he owns an island off of the coast of California. Creativity is supposedly associated with altered states of consciousness, meditation, sleep, REM sleep, right? You've heard of this. And then, oh yeah, one of my favorite. The mad genius. Creativity is associated with bipolar disorder and schizophrenia and bipolar disorder, ADHD, major depressive disorder, ADD. These are all false category formations. You can, of course, also be creative in a state of arousal, in a state of focused attention. We all have been creative. The opposite, I don't even know what the opposite of lateral thinking is, maybe medial thinking. Yeah? Of course, the vast majority of people are very creative in a normal state of consciousness, whatever that is, and then mental illness people. This is such one of those myths. I have talks on showing data on how that doesn't work. But I give it to you intuitively in case you held on to this belief for a while. The vast majority of people who are creative are not mentally ill. The vast majority of people who are mentally ill are not creative. The association is the other way around. In fact, creativity is associated with mental health, not with mental illness, if there's any association whatsoever. But this is one of those myths that stays on and stays on and stays on. So, let me switch here, gears, halfway through. Real mechanisms. That leaves us with very little, almost nothing. If you demolish all what we've believed in or thought of, where can we go from here? And for that, I have to introduce you to some real mechanisms, and there we go a bit more into neuroscience, things that are not that familiar to you, perhaps. The first is, we can't study creativity. We have to break it into types. Different types have completely different mechanisms. And when we throw them into one pot, we end up with nothing at all, because one type may increase attention, the other type may decrease attention. You throw them together, you can't say much or anything. Without breaking these things into types. That's, by the way, also why we in neuroscience don't study thinking. For the same reason, we can't study creative thinking. What do neuroscientists do? They study memory, they study attention, they study perception. This is what we're going to have to do with creativity. There's probably no such thing than creativity as a single unit, as a single thing. I come back to this a couple more times, but think of it this way. We all think of creativity as a trait, as one single psychological trait, as one mental faculty, like Steve Jobs had it and my grandfather didn't. Notice the singular in that sentence. Yeah? The singular is, he had it. Yeah? In the brain, however, this is extremely unlikely that there is a signature, a neural signature for creativity. It is just too complex. There are too many things involved, just like with thinking. There are too many processes that you will need to look at. So there is no one thing that you will ever associate with creativity. Okay? So the different ingredients that all types need to have is that they all differ in neuroanatomy, different brain areas for different types. They're all different in the kinds of processes that they require to think creatively in a neural network. Okay? Some of them are cognitive processes, like attention, like working memory, like reference memory, like long-term memory, like perceptual processes, these sort of things. And some of them are computational processes. In fact, evolutionary algorithms, the last part here, is such a computational mechanism. And I go easy on you in case that the computer creeps. Evolutionary algorithms. We need them. Otherwise, we can't get into mechanisms, because that's how your brain works. You can't think of your brain when you tie neuroscience to psychology. That's, by the way, true for almost all of neuroscience or cognitive neuroscience. You cannot tie mechanisms the way we will understand them in the future to anything that you can relate to intuitively. I already said this. A comparison I often make is the computer screen. You use your mouse and click on something and drag it into the trash. But this is not how this machine works. Okay? This is the interface screen that you have. Your intuitive psychology of how you think you work is not how the machine operates itself. Okay? The mechanisms will not mesh with anything that you understand. I will not give a talk ever, I think, in my life, where people at the end leave going like, that's how it works, that makes sense. Yeah? That we'll have to bury, that we have to lay to rest, that we have that connection. Yeah? So let me tell you the necessary assumptions on neuroimaging. What do you have to do in order to even conceptualize that you can take somebody with a test, put them on the function MRI, some brain area lights up, obviously you do a cognitive test, something has to light up, But what does it say about how we conceptualize creativity? Because it seems to say the condition is that you do normal thinking. Whatever that is actually, because we don't know what normal thinking is either. Yeah? But let's say in a control condition you have normal thinking, and then you do a creative task, which is it's a divergent thinking task. Yeah? The conception that you have is that creativity is something different, separate. It's an entity, the spark as I call it, that gets added to normal thinking, and that different entity I can picture with a function MRI. It is so different that I actually can see it with a function MRI. I can subtract it as if it is one thing. This is very, very unlikely that this is how we are created. It is much more likely that the creativity is embedded into the circuitry. Yeah? The way I often say this is like salt in the ocean. You can't separate unless you have a proper instrument. What's this reverse osmosis process? That you can get salt out of the ocean. Otherwise, it's in. That's that. Yeah? This is what I call the vaudeville conception. It essentially proposes that in terms of neuroanatomy, creativity is everywhere. The entire brain participates. It's a bit like asking a neuroscientist for the neural location or the brain location of thinking. It's everywhere. Or, as I often say, it's in the brain still. The creative part is the same, that the whole brain takes part with it. We know this from two concepts that are actually a little bit difficult to explain and not needed. Non-linearity, that there is always some novelty in the system that processes information, and modularity, that we know the brain is compartmentalized. So in a sense, look at it rather this way, that if you want to do jazz uncreatively, or uncreative parking, or uncreative math, or uncreative art, you use a particular brain circuit. We know that. When you are creative in these, like you do creative jazz improvisation, when you do creative parking, yeah, which some people do, or creative math, that needs to be in those circuits. That means the creativity that you will find in a jazz musician, in terms of brain mechanisms, is very different in terms of neuroanatomy than those you'll find in a dancer. Yeah? In another way, this does not happen. There's not one place that adds sort of the juice to the soup or the. One way I often explain to this is the following way. You can use a satellite to find England, the country England. Actually, it's not a country. Maybe soon it will be. But you know, the entity England. Yeah. You can't use a satellite to find all the people in the world that speak English. They are distributed. They are embedded. So pretty much we can be sure of that whenever you read something, that something in the brain is associated with creativity. My recommendation is run. You're not talking to somebody who knows what they're talking about. And this pops up everywhere. Now, after the right brain theory, the next sort of front runner for the location of creativity in the brain was the prefrontal cortex. Makes sense? It's at the apex of human mental faculties, same mistake. But sometimes maybe but not for other types. And now currently, there are some people proposing it is a network called the default mode network. Maybe you've heard of it. It has gotten around. It's gotten famous beyond neuroscience. It's the same problem. It's an upgraded type of phrenology. It does not work. Okay. My jazz. That lets me switch to a completely different mechanism. I spent about 5 minutes on this. Okay. That I also would like you, if you think about your own creativity, of how you proceed with finding your way in a creative project of any type. And that's evolutionary thinking. Essentially, what you do when you are creative, your neural networks run evolutionary algorithms. Let me explain. Okay? First, the wellspring of all of our inventions, the artifacts of our civilizations, all come from the brain. They do not come from your left toe, they do not float mid-air. You need a computational machine, the brain, in order to change information. That means the creativity is always based in a brain or the brain. Brains produce culture. Second, now evolutionary thinking in culture is a debate that has very often generated more heat than light. Just like the Darwinian thesis in biology for so many years, 150 years plus. But we all agree in neuroscience, pretty much, that the basic evolutionary logic applies to human creativity. Let me explain this conceptually. Okay? When you are in an unknown problem space, that means you have a problem that needs a solution, and the solution needs to be creative. You're in an unknown problem space, and somewhere there's a solution located. You have no idea where in the problem space the solution is located. Okay? If you knew, you wouldn't have to do any creative thinking. Yeah? You don't know where the solution is. Yeah? How do you find it? You have to make a step. Do you know whether that's the right step? No, you don't. So you have to take more than one step, and you immediately have a variation process. You have variation on your ideas on how to find a proper solution. Some of these ideas you keep, some of them you don't, and you immediately have a selection process. The next step you take will be based on the selection you've done on the previous step, so you have an inheritance process. We all agree on this variation, selection, inheritance as you move in your thinking process, in your creative process forward. It's a variation, selection, inheritance algorithm. It's an evolutionary algorithm. We all agree on this more or less. So you can be sure that your neural networks run evolutionary algorithms. And that will tell us already a lot, this computational principle, about what do we have to look for when we look for creativity in the brain. We know one more thing, and that gets a bit more complicated. Okay? And that is that we know culture is a variational system. It's essentially a Darwinian system. It's not a neo-Darwinian system, but it's a Darwinian system of variation and selection, of how you perceive. But it's not the one that runs creativity in the biosphere. When nature creates, like for instance our bodies are very creative inventions, over millions of years of solutions to environmental problems. It's a very creative solution, the body we have. I wouldn't have come up with it. I would have gotten an eye in the back, or certain. It's very, but the solutions are very creative. Yeah? Nature does this blindly, famously. It's blind. It's one of the things that lots of people have problems with in terms of a Darwinian thesis in biology. The biological evolution has no direction. That's not the case for us. We do not create blindly. We have expertise, and that expertise helps us with our evolutionary algorithms. Ours are, the last two words in there, partially scientific. We can take a guess of where a solution might be. I will look in this part of the solution space, not in this part of the solution space. Nature will look in all parts and go all 360 degrees. One will work, the rest will be thrown away. But that's the path. I will do this very wasteful. Yeah? I will not do this, you will not do this. Yeah? We'll have a heuristic algorithm, that's what it's called, really, where we take a part of the solution space and only search this for a possible solution. The rest is discarded, which is computationally a very smart thing to do. But for that, you need a brain, and you need a brain that can represent the world. DNA cannot do it. DNA cannot represent the world. And that's why it cannot produce heuristic algorithms. That hones the question that we have to ask in neuroscience, because now we know what to look for. We have to look for what in the brain could possibly constitute a variation process, what could constitute a selection process, and how do you memorize things? That means what is an inheritance process? We understand this very well in biology, DNA, how DNA codes information, but we have a problem in neuroscience. We have no clue how the brain codes information. None. It's a basic problem in neuroscience, that we do not know how we represent the world. You represent the world the way it is, your representational format. We got no clue what the code is, what the code is. We haven't found the equivalent of DNA for neuroscience. That means we do not have mechanistically any good idea of what a variation process is, because for that we would need to know what the code is. So what gets varied? We don't have an idea of the selection process, and we have no idea of the inheritance process. Yeah? That means how you memorize information. The idea that has been floated the most, that's very famous, is from Richard Dawkins about memes. Memes is essentially a way to propose an inheritance process in cultural evolution. Yeah? But there are lots of people who have doubts about it, and for good reasons, good scientific reasons, who have doubts about it. So that leaves us with one question, and that's a question I've been pursuing for the last 5, 6, 7, 8 years. And that is, we can still investigate. Oh, I just said that. How do we get partial sightedness on an unknown problem space? So you have an unknown problem space. That's true for an artist, it's true for an engineer, it's true for a scientist, it's true for people in business. When they have to do creative solutions, you can think of yourself as being an unknown problem space. How do you know to look only here and not there? Okay? What is the basis for these heuristics? Otherwise, we are all not willing to consider creative artists, creative engineers, creative scientists, some sort of special class of prophets. Yeah? We need a mechanism of how we can constrain the solution space before we start working. Okay? And that's a proposal that I've made for the first time about 4 or 5 years ago, and that is what I call ideational RPGs. It does not stand for rocket-propelled grenades, which is what, if you're in the military, you know what an RPG is, rocket-propelled grenade. It stands for representations of predictive goals. Let me explain. The prediction framework, which is the title of this slide here, is something that has become the main paradigm of neuroscience. If you even haven't heard of it, you will hear it from me, and if you haven't heard it from me, you will hear it sooner or later. Because we are not thinking, we're essentially thinking in neuroscience of the brain as a prediction machine. And we're not thinking in terms of, this is one of the things the brain does. We're thinking it's the main purpose to have brains in the first place, to predict. This particular paradigm has bulldozed all of neuroscience. Essentially every single field of the cognitive neurosciences now uses this framework in order to understand its results, its findings. We have known this first in the world of learning. We understand this also in perception. Let me give you a stupid example. For instance, if you walk out here and call the elevator, you press the button, yeah? And the elevator doesn't come, it takes like half a second longer, you'll be immediately surprised what's wrong with the elevator. You can only be surprised if you had an expectation. You predicted what would happen given your behavior. You behave in some ways, you predict that behavior. And if it violates your predictions, yeah, then you have to adjust. You learn only when something violates a prediction. We know this because we also know how dopamine signals are tied to learning, yeah, of how your expectations are violated. We understand now memory as a prediction mechanism. That sounds weird because memory is for the past, prediction is for the future, but look at it this way. Why do you have memory? It's not so you have fun and reminiscing about the past. It is so you have information to feed your simulation machines to predict the future. You hold information in your head primarily as a simulation device. The more and better information you can feed into your simulator, the better you can predict the future. That's why you have memory. That's the whole purpose of keeping information in your head. And this is also true for creativity. Now, when you walk an unknown problem space in creativity, you will make predictions of where a solution might be located. Okay? And the computational principle behind an ideational RPG are essentially representations of the predicted future. You do this all the time to imagine the future, and you also do it when you're creating. I give a couple of examples to explain the line. Nature doesn't do this. Nature will run straight into the mountain. Of course, it will also run this way, yeah? But I will only run this way. Yeah? It's more of an efficient system, why cultural change is so much quicker than a biological change. This mechanism depends on the frontal cortex. And now I won't go into specifics of this, but we know quite a bit of how you represent the future, how you imagine the future, and we can tie this to your creative abilities. I will leave this out, except for the last thing, because I've already explained the first three. The last thing is, an argument very often brought against the possibility that creative thinking is an evolutionary algorithm, that you can abstractly conceptualize mathematically as an evolutionary algorithm. It's that we have foresight, that evolution is blind, and we are not. We create with purpose. Yeah? We have an intention. But purpose and intention are mechanisms that we can explain exactly with this prediction framework. You have an intention, you have a purpose because you predict the future, or you attempt. Essentially, it's an educated guess that has the probability of being right greater than 0, and that helps you. Finally, this is my second to last slide. I want to introduce you to a proposal that I first made 14 years ago, but I reiterated with a lot more detail of what we should do with creativity in terms of dissecting it into different types. I've proposed that we have 3 types. I call them the deliberate mode, the spontaneous mode, and flow, or the flow mode. And each one can be tied to a different set of mechanisms in anatomy, neuroanatomy that is, the processes, cognitive and computational, and 3 evolutionary algorithms. You get a very complicated graph that I will not go through here. If you have more interest in reading this, the last paper that I showed you in the beginning of the talk has exactly that information in it. About explicit system, prefrontal cortex systems, evolutionary algorithms, their sightedness, something called transient hyperfrontality. Each one can be tied to different neural mechanisms. Here's the advantage of this thing. Once you no longer try to investigate the whole beast, the whole of creativity, which is so multidisciplinary, so variable, so multifaceted, you have a chance of finding, and here comes the important part, one mechanism of one aspect of one type. And that is what we ever going to, if anybody ever tells you the neuroscience of creativity, yeah, creativity is associated, stop that person, don't even let it finish a sentence, yeah? Or run, one of the two. The whole of creativity is not associated to anything. I can be pretty sure on this because some of the types are diametrically opposed in terms of these mechanisms. And we know that. We know, for instance, for some types you need to focus. For others you don't. A third type would be flow, where you need to move. Yeah? Movement, as soon as you move, everything changes for you. Yeah? And that no longer has any bearing to the deliberate mode and the spontaneous mode. So when you think you can tie creativity to the default mode network, or the right brain, or the prefrontal cortex, you will always deal with phenomenon. That's my last slide. Once I see my Phoenicians, I always have my last slide. Oh, by the way, you have enjoyed here pictures of AUB on the campus. I hope you like this. It gives you a flair, a little bit of the campus we work on. A summary of 4 types, or 4 not types, 4 points that bring this sort of together, and we can start having a discussion on this. The current neuroimaging paradigm that is now dying, but it was still in full swing about 3, 4, 5 years ago. The current neuroimaging paradigm is theoretically incoherent. And there are only very few people left who still haven't gotten it, who have so much cognitive dissonance. That will continue. You can't stop them. But I think the fact that no one is joining this paradigm anymore is, I think, evidence that we're finally getting through to people. And it qualifies as a form of phrenology. And phrenology is the quintessential pseudoscience of neuroscience. That's the last thing you want to be. If you throw the P word, phrenology, into a neuroscientist's face, they will make all attempts for a lot of time to put ideological distance between them and phrenology. It's a cuss word for us, but that's what some of my colleagues are still doing. Creativity must be broken down into tractable and intractable types. There's no such thing than a neural signature for creativity, for the whole of it. Yeah? It's too complicated. It's too distributed. It's too embedded. 3, we need to understand prediction processes. It's a key part of how the evolutionary algorithms is run in neural networks. That means also, and don't get scared on this, yeah, once we understand them in terms of mechanisms, how we can implement them in machines. not in this machine, in silicon machines, not in carbon machines. The evolutionary algorithms, once we understand the mechanisms, there's no reason not to duplicate them in a machine. I know it gives people the creeps thinking about creative robots, quite a calm, because ultimately we are creative robots. This is a machine. But that is a completely separate discussion, I suppose, on philosophical matters that we can debate at some other point. And it's the prediction processes via representations of the future that are the basic mechanism that upgrades, as a side of this parameter, the evolutionary algorithms that run on the neural network. We can be pretty sure that this is a direction we need to understand in order to understand creativity. As I said, give up your intuition, it doesn't mesh with your intuition. And then the last thing, based on current knowledge in neuroscience and evolutionary theory, we can, or should creativity initially divide into 3 types. That's my proposal, and I'm pretty sure it will not last long until they will get subdivided even further, because even that is very crude and very vague. But we've got to start somewhere. And that's my thinking. So thank you.
Opening up the floor for questions. Yeah, Arne.
Yes, sir.
I have a very fundamental question. I'm not in this field, and you use a lot of precision with a lot of technical terms. But the one thing I still don't really feel like I have a grasp on is exactly what is meant by creativity.
Oh, neither do I. Join the club.
Okay. And how do we know if we've captured it?
Yeah, very good. We have a really big problem here, defining it. We all shun away from it. Yeah? So the definition that we use is very broad and useless to bring this or to make this into an operational definition that we can bring into the lab. The definition of creativity that we generally have agreed on is that it has 3 elements, and this is used by people that cannot have philosophical discussions, that need to make practical applications, and these are clerks and patent offices. The US Patent and Trademark Office has decided on what creativity is, and we use that definition. And that, I guess, has to do a little bit by the fact that they have to be practical about it. Yeah? We cannot discuss this matter until the sun goes down. First, a product has to be new. So first of all, we define creativity through the product that it produces, not the mechanisms. Okay? So a product has to be new. That's obvious.
So innovation.
Yeah, it has to be new. But there are lots of things new. Still, I mean, creative. Yeah? The second is that it has to be functional. And by that, we typically mean, not just in an engineering sense, it has to work, but also for artists, it has to speak to us, whether it has some connection to beauty or symmetry, or violates this in some form. That's what we mean by functionality. Yeah? It cannot be useless in any way. And then the third criterion.
It's almost relevancy.
Yeah, you can use that word too. Yeah. I've heard a bunch of functionality also. A third criterion is the one that's disputed the most. And that is, if you think about it, if you stand in front of a picture and you say, okay, this is new. Yeah? This also works as a sort of composition, as a design, but it's not creative. So you have these two. The third thing that we usually consider as a criterion is surprise. It has to violate your expectation. You must go, I would not have come up with that. That's creative. Yeah? So these 3 things we use in order to define creativity. And it gets more complicated from there. Not only do a lot of people don't agree on this definition, the third one also has a time perspective. For instance, I can produce something that you, as an observer, find creative based on these 3 things. But society doesn't. Yeah? And maybe I can produce a piece of music that doesn't sell. So we don't consider that very creative. Or do we? See? You're shaking your head. It's a problem. If we use an indicator or functionality, like, for instance, selling a record, yeah? Picasso, and how much money you generated, or how much citation you have on a paper, how creative a scientist is. We have to have some sort of operationalized definition. It's very difficult. And then comes whether society accepts this. So there's a selection process on all the products. So the clerk in the patent office might say, that's creative, it gets a patent. And then it flops. Society doesn't accept it. Then also 100 years later, people will say, this guy was ahead of his time. They didn't think it was creative, but it's clearly creative, based on these 3 criteria. I can tell you a couple other things that we're discussing in the field of how complicated it is to have a precise definition. We don't have one. We have a vague one. But then we also don't have a very good definition of what a gene is. You still have very good genetics as a research field. You can sometimes make progress by not settling all the definitions and all the parameters to a T. And this is what we're going to have to do.
I think that's very helpful. I mean, the second thing, functionality and relevance, there should be certain subjective shading put on that. So you could get into a situation where what some person regards as creative and other ones not, simply because of their own personal factors when they're carrying out that evaluation. But that's very helpful. Thank you.
For instance, the creativity that children are supposed to have, they're so creative. And we use the criteria, none of them ever gets a patent, because what they create is not or not functional. So is many of the inventions of people who are schizophrenics. They do stuff that certainly, I mean, some schizophrenics come up with stuff that is so surprising, you wouldn't come up with that. It's very surprising, it's very new, and it's not very functional.
But if it's your child, it needs the relevancy, right? And it may be innovative, and it could be surprising, and so it would be creative for you, but maybe not for somebody else. That's what I was trying to suggest.
Yeah, and that is exactly where the problem starts.
All right, thank you.
Who thought this was easy? Yes.
Yeah, so you mentioned that something about jazz improvisation is different than different type of creativity than dance creativity.
Yeah.
How are the different creativities different?
That's a very good question. We don't know, but we know for sure. Well, don't think of different domains as different types. Those are 2 different things, okay? The underlying mechanisms of terms of evolutionary algorithms are the same, So don't think of linguistic creativity different than visual creativity. These are domains, not different types. You will see my types were content independent, So there's no
dance
musical
would be more
creativity.
like flow, and jazz improvisation would be like cognitive.
Well, jazz improvisation certainly falls within flow,
Oh.
And it's a completely different kind of creativity than when you write music. You sit down and you can revise. In jazz, you can't revise. The tone is out. That's it. You gotta go to the next. So it's in the moment. It's a typical sort of flow situation.
How would you describe the difference though?
I have, you remember the talk I gave about flow? I have a whole different talk on flow, because flow is a very different type of creativity. I couldn't go into this, but it has to do with the fact that it involves the motor system. And as soon as you involve the motor system, so mathematically, or when I write music, I can sit here and not move at all. But as soon as you move, like in jazz, or doing sports, your brain changes so fundamentally that you will, also with brain areas, things like cerebellum, the basal ganglia are involved, which are not involved if I don't move. So that has to be taken into account.
Arne, on the topic of flow, knowing that it's a very large topic, you have a lot of art therapists in the audience here, right? And there's a lot of really great information that's coming out that speaks to the health benefits of the flow state, physiological responses, whatnot. So would a way of remembering what a flow state is about, and if I'm recalling correctly from what you talked about, there is an energy exchange between consciousness and unconsciousness that involves an integration or a communication between cognitive and emotional processes. Would you also say that the flow state requires enough attention to be in the moment with what it is that you're doing, but not so much that you think too much about it and have to become so focused?
Yeah, so
Am I remembering
let
it
me-
correctly?
Yeah, let me
I
unpack
hope
this.
so, I really hope so. Because that's what I talk about all the time.
Okay, let me unpack this a
Okay.
little bit. 15 years ago, I made a proposal that the flow state has to have two elements in terms of brain mechanisms. I'm a neuroscientist, so for me, it's a brain mechanism. One is what I call transient hyperfrontality. You have two large systems in the brain that process information, one explicit, one implicit. The explicit is conscious, or can be conscious, and is very analytical. The implicit is not. It's a very simple system. It doesn't have the computational complexity to produce something that can actually be conscious. It's just mostly a computational issue. When you downregulate your frontal cortex, your implicit system has more of a chance to drive the behavior. And if the behavior is automatized, you can get into a flow state. You cannot get into a flow state with your frontal cortex not downregulated. This has been generally accepted as one of the key mechanisms. That's, I guess, what you meant by the exchange. Although I like unconscious conscious as much as
I know
explicit implicit.
those words, right?
Yeah.
Yeah, I should have chosen explicit and implicit.
Yeah.
I know, I should have used a different language, because we talk about consciousness and unconsciousness, which evolved from, well, we think about Freudian terms and psychodynamic theories, right? And when we talk in computational mechanistic terms, we are automatically not going to be heard as readily as if we use terms such as implicit and explicit.
No, unconscious is fine.
Really?
Yeah, 99.9999% of everything the brain does is unconscious.
Okay.
Yeah. So anyway, because computationally, this is the easier way to do it.
Okay.
Yeah? But to go back to your question, or to your comment, I guess there wasn't a question in it, or was there?
It was more of like a bridge to talk about flow and a way to remember things.
Flow is a very special state, but you also have to remember that creativity and flow is not the same thing. It can be, and I guess that gets best back to these health benefits. You can be in flow without being creative. Okay? And that's actually most of the time you're in flow, you're not creative. In any sort of way. Most athletes that get into flow are not creative. And there it has to do with optimal performance, with optimal output. They get the gold medal, but they're not creative. Yeah? You have to see also that you can be creative without being in flow. There are two other types of creativity, so you can't conflate them. Okay? Most people who are in flow do not create anything creative. But you can, and it facilitates it in a particular situation. One of the things that we know is associated with flow are these health benefits, and they have nothing to do with the creative part. Okay? That when you downregulate frontal cortical networks and are in a state of hyperfrontality, what you lose are the higher cognitive functions that are sort of meta-analytical about everything, that dissect everything. And you just let, that's the whole point of flow, flows. You let things go. Yeah? And that produces the health benefits in and of itself in terms of calming you down. And that meditation does very similar things in that case. Meditation and flow are also not the same things. Not in terms of the brain mechanism, but also cognitively. So the health benefits come from this hyperfrontality in large parts, which calms down autonomic nervous system, endocrine systems, stress responses, and so on.
Which have great implications for our work as our therapists.
Yes.
In terms of helping people enter a state or a state similar so that they can...
Yeah, so from the little I understand about art therapy is of course not only about your creativity, but also the therapeutic effect of being in the flow state.
That's a part of it. But like creativity, is it fair to say that our therapy is then a compound construct of sorts, in that there are so many different...
Sure, it's a multifaceted
It's
thing.
so multifaceted, it's difficult to isolate what it is, the mechanisms that make it what it is.
So is your understanding of democracy. Yeah? I cannot ask you in a function MRI, think of democracy, and then one brain area lights up, and it will, because ultimately you're doing a cognitive task, and said, that's the brain area for democracy. You can see already the problem. There's no Jesus area or Muhammad area that I can take out and make you a Buddhist. Yeah? The brain does not work that way, and I think when it comes to creativity, we make this mistake all the time. Yeah? But we don't. When I make fun of it that way, right? You immediately see the phrenology. right? Yes.
So how much movement would one need in order to become in flow? Because some artists, like our painters, they work very tediously and don't move very much.
Yeah, correct.
And then others use the big old canvas and then just really use a lot of movement in order to express.
Yeah.
So,
Well, you can go to dancers if you want to. They move their whole body, and it can be very creative. Yes. I have no idea. Nor does anyone else. I can tell you that of how much movement is required.
Yeah.
And it is domain specific. And here the topic does matter. Yeah. But the general principle of a hyperfrontality will be true for both. But how they then implement the particular content of their field, whether it's a dancer or it's a painter, yeah, that would be embedded into the circuits that do that thing normally. You understand?
Actually, I was trying to come up with a counter example between if I'm improvising music and singing it, or if I'm doing it in my head. And I thought I had a counter example, but then I realized when I was doing improvisation singing in my head, I was actually engaging the muscles that I would use to sing.
Yeah,
So
yeah.
there's some movement involved.
Yeah, but you also correct yourself to some extent. But this sort of, and then we get into another topic, and that's the topic, the relationship between creativity and imagination. Also not the same thing. You can be very imaginative and be very uncreative. Yeah? Yeah? I can imagine things and there's nothing creative, it'd be functional. I imagine what I have to do tomorrow morning with all the stuff that I have to do. I imagine this and nothing will be creative about it. And you can also be creative, yeah, without any imagination whatsoever. Flow is a very good example. Because the whole point is that your imagination system does not operate. You have a feed from perceptual input to motor output, and it cleanly bypasses your consciousness. There's no imagining this. What would I do next? Because if you do that, your flow is gone. Yeah? As soon as you have metacognitive processes overriding the motor output, yeah, you're no longer in flow.
So if I'm playing a word game and I see 8 letters and I don't think about it and the word just comes to me, is that a flow experience? Or-
And no, I think the flow would be better. That comes in the sequence. If this happens 20 times in a row, yeah, when you play speed chess and it goes bing, 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 sometimes you're just in the zone like that. Yeah? And so one move probably wouldn't. But if that happens in a sequence of events, yeah.
So what process that solution to come without the linear thinking of arranging the letters?
Yeah. The key event to this is optimization. The input has to be mapped to the output prior. As soon as the input comes in and you have to weigh options, flow is gone. Yeah? It has to be a mapping. So it comes in, goes out, comes in, goes out. The whole idea of
clear,
flow.
that's what I'm talking about. I don't understand this at all. I will see 8 letters and my brain will tell me the word that it
Yeah,
is
because
without
they're
any
mapped.
conscious thinking.
Yeah. Yeah, it's unconscious thinking. I would prefer the word mapping in this sense of a perceptual input to a motor output. And this is so automatized, yeah, so many times over. This is why you're rarely, if not ever, in flow. Yeah? When you learn something, yeah, because you know, how does this work? How does this work? And then you feel weird about it. You're only in flow if the movement itself is completely automatized. Yeah? The more you practice, the more chances you have to be in flow. And that's true for the techniques of a painter, for a tennis player. Whoever is in flow, what you will find is that this requires oodles of hours of practice before that mapping process can be so hardwired, I don't like the word, but I guess it is so ingrained into the neural networks that when your consciousness goes and is down-regulated, not shut off, down-regulated, that mapping process works like a rapid-fire thing.
And
that is the process.
athletes are the constant example they use in flow. They're having to respond.
Yeah.
So that response is determined on an outside force.
Yes.
So that where is that coming from, the response? Because it's not something exactly they've done before.
No, it's driven directly by the perceptual input. So you get input into the system, and there's a map to an output. And it comes like this. And that leads to the next perceptual response from the environment and your output. And there's an actor-environment interplay that is rapid fire and automatic. And it's binary. And there's no analysis. Did I just do this right? I don't know. You just move on to the next, and move on to the next, and move on to the next. Yeah? And that's when you get this feeling of things just flowing. Mike Csikszentmihalyi used the correct word for this procedure. we have had a lot of email exchanges, and I talked to him about the hyperfrontality theory because he didn't like it in the beginning. Because he thought, like many people, he's not a neuroscientist, and he thought it was fascinating because his conception of flow was that it is a higher brainstem. And when I told him that the frontal cortex must be downregulated, otherwise that makes no sense, yeah? From a neuroscientist point of view, yeah? he had to swallow that first. It took me many emails to convince him, but he's convinced. He doesn't mind.
One more comment. So the overall picture I'm getting is that there's a difference between creativity and artisticness.
I don't know what artistic is.
So being artistic and creativity, there's just a difference. A lot of people will like.
I don't know what you mean with that word.
Artistic. So
Yeah,
somebody
maybe.
who does art, and you're
You can
saying
also
some
use,
people.
you can also use science. You can also use that scientific or any field. You know.
Yeah, entrepreneurs are very creative.
Yeah, some of them.
Yeah, right?
Some artists. I've seen some very uncreative ones.
Right.
Yeah, I've seen some very uncreative scientists.
I'm just saying, generally, when people do art and another person doesn't really do art, they say, oh, you're so creative, but in reality, they mean you're so artistic.
I know we're not getting into the concept of what is art because then you're going way above it. Yes. And then,
I have a question, but I don't want to move us from the topic at hand. In sort of, I love the idea of the brain as a predictive machine, and these ideas of lightning flashes that sort of guide us along the way. Similar to that, what comes immediately
you can call
next?
them beacons of light in the distance. Beacons of light
I'll
in the
take
distance.
beacon. What comes immediately next in this field and in this research? So if the goal is to understand the neuromechanisms and to subdivide these domains as minutely as we can, what happens immediately next? What's our next step in research?
We are still quite far away from the Holy Grail. And the Holy Grail would be an experimental paradigm that you can use to falsify. We need, for us, everything is the F word, falsification. Yeah?
Yes.
We need to see and do an experimental tests of theories that hold water. And then we can move forward with the data that we're getting. We're scientists, we're a field of science. And we're still, I'd say, a good 10, 15 steps, whatever these steps are, away from such a paradigm. The paradigm that we've been using so far, I have debunked. And so, in order to get a new paradigm, hopefully we're not rushing into the next phase of pseudoscience. We have to be theoretically solid, conceptually sound, and with that, that means that any step forward has to be tied very carefully to what we know of how the brain functions normally. Then we can be sure that the mechanisms we are hunting, and we're still quite far away, and then even then, you will not have a paradigm that tests creativity.
Sure.
What you will have is a type of a piece, of a section that, in one particular instance. But the key thing on this is that then ultimately also will allow us to mess with the process. Because I don't think we can reliably enhance creativity unless we don't understand the underlying mechanism. Now you think maybe that is too reductionistic, but if we also want to implement it in a machine, in a robot, for instance, we need to know exactly what to program in. We're very far away from understanding the inner universe the way Newton never understood the outer universe, and that's 500 years ago. So, more like Archimedes.
Thank you.
Greeks. We're literally 50, depending on how you count, 50, 100 years of solid neuroscience worth of understanding. 100 years ago, we didn't even understand what the synapse is. Yeah? And that's 100 years ago. That's your great-grandmother's lifetime. Yeah?
I love the fact that you are there, and I love the fact that you are there.
I'm here.
That you are there in that space, that you are so far away, because it is inconceivable for me to enact something so powerful in, and yes, the mind is a machine, but to think that creativity would be translated into an algorithm right, I recognize that it is in all actuality but that neuroscience would possess it in such a way frightens me, and so I'm so grateful. I'm so grateful that you're way out there.
I mean, so far away from actually doing it. It'll come in your lifetime. And if you think genetic engineering is our biggest problem in the next 100 years, it's neuroscience. What we will be able to do will go to the very core of what you hold dear in terms of your individuality, your freedoms, your liberties, the first 10 commandments of the constitution of your country. We can all mess with it if we know the mechanism of it. That's why we need this also to go forward in an ethical manner. And I think there's within the field of neuroscience, there are lots of neuroscientists very aware of this, that we will have to have societal oversight over what we will find.
And can we continue the Q&A with the reception?
And a glass of wine?
And a glass of wine.